So good morning, everyone. I'm Luiz Silva. I'm a professor at Virginia Tech, and I lead a group called the Commonwealth Cyber Initiative, or CCI. And I'll talk more about CCI tomorrow, so I won't explain too much. Just think of it as a large consortium of universities in Virginia. And one thing that we did in CCI from the beginning was to create a testbed. So we got started in 2020, so we're about 4.5 years old right now. And for various reasons, our focus is cybersecurity. But for various reasons, we decided that part of our research infrastructure that we should create was what then was thought of as a 5G testbed. It quickly became clear that 5G was already established, and so we're focusing on the next generation. So we called it an XG testbed. There's a lot of work in CCI going on in wireless networks. Virginia Tech and other universities in Virginia have been traditionally very strong in that area. And then there's a lot of work that's aligned with AI. So AI security, both using cybersecurity to improve AI or to protect AI against cyber attack, and also using AI to improve cybersecurity. So in things like intrusion detection and those sorts of applications. So we decided that this testbed should sit at the intersection between some of the work going on in 6G, things like virtualization, softwareization, open systems, and so on, and the work going on in AI. So what we have is an AI native network testbed. We needed to build it out of open source components because our focus is cybersecurity. We are a research group, research and innovation and workforce development. So we needed access to the internals of the various systems that were being tested. So we early on decided to build it end-to-end out of open source components. In terms of hardware, we rely a lot on USRPs, and then the whole software stack from the RAN to the core is open. So we use SRS RAN a lot. If you all have worked with SRS, SRS is a startup, a spin out of a lab where I used to work, where Dan now works at Trinity College Dublin. So we have a very strong connection with them. We also use OAI and then various open cores and open systems to support the AI components of the testbed as well. Oh, I should say that this is slowly changing or being supplemented with some equipment that's not open source, that's proprietary. So through our engagement in projects like Accord, we are now incorporating additional equipment that's actually vendor proprietary. So right now, for example, or I shouldn't say proprietary, but for commercial equipment. So right now we are testing as part of Accord interoperability between Nokia systems and Fujitsu RU. So a Nokia CUDU with a Fujitsu RU, and then all of that is using equipment, test equipment from Keysight. So in the last month or so, we have received about $5 million worth of equipment into the lab for these tests. And then the next thing will be to test a RedSys CUDU interoperating with the Fujitsu RU. So little by little, or maybe not so little by little, kind of quickly, we're incorporating more commercial equipment on top of the existing equipment. The indoor part of the testbed sits in Arlington, Virginia. For those of you who don't know, Arlington's about 3 hours south of here, so in the outskirts of Washington, D.C. Virginia Tech has a location, a facility in Arlington. That's where I'm based, as well as a location in Southwest Virginia, which I'll show in a moment. So that's our grid. We have about 70 USRPs, a mix of X310s, X410s, and N310s. It looks suspiciously like, WinLab. It's not by coincidence. When we built our testbed at Trinity College Dublin about maybe 10 years ago or more, we were inspired by this, so we built a grid. And then when I moved to Virginia Tech, Then of course we kept the grid, and the grid has evolved. It looks a little bit different, but it's certainly inspired on this. Then of course all of these are connected to a bank of servers, and then you have VMs in those servers that control all of these ranges. We joined the ORAN Alliance a few years ago, and also engaged a lot in development for ORAN systems, as well as developing the workforce. So in the beginning, there was no one that we could hire to actually do this work. So we had to kind of build the workforce ourselves, and that's part of the outcome of all of this investment. So this is the part that sits indoor in Arlington. We have 72 radios on the grid, and then a number of additional radios that we use for further experimentation. Then there's an outdoor part of the testbed that sits in Southwest Virginia. So this is a map of Virginia. This is where DC is. So we are a bit north of here right now. This is Southwest Virginia. That's the main campus of Virginia Tech. Virginia Tech is one of the few universities in the US that has its own spectrum license. So we have a license for CBRS spectrum that was auctioned off a couple of years ago by the FCC. It covers 2 counties in Virginia, including the county where our main campus is. So we are deploying an outdoor test bed there. It's a 1.5-mile corridor, 3 base stations. They sit on top of 3 buildings. And then it's a mixture of commercial equipment and an SDR, USRP-based equipment, using our own spectrum. So we're using CBRS spectrum. The outdoor testbed then connects to the indoor testbed in Arlington. So that also allows us to experiment with systems where the CU sits in one place and the DU and RU sit 270 miles away from that place. So there's about 250 miles between Arlington, Virginia, and Blacksburg, Virginia, where the main campus is. We've been conducting lots of research, lots of experiments. These are just a couple of examples. Last year, we presented at IEEE MILCOM and got the Best Demo Award for this work that looks at end-to-end, zero-touch, ORAN-based resource allocation. So it's an example where we use some AI to detect the level of demand from end users and then allocate resource blocks to these users on the fly. So our example was first responders versus more traditional users. On the right is another set of experiments looking at disaggregated near real-time RIC components between different locations in the US. We published that in the IEEE Transactions on Network and Service Management very recently this year. In addition to the testbed grid that I showed, we also have millimeter wave equipment. At 1 minute. Almost done. So we have millimeter wave equipment that comes from InterDigital. They lent us the equipment, and I think they'll never get it back. But I don't think they want it back, so they're happy that we're using it for some of this research. And that's in particular. So those examples are research on security for millimeter wave systems in the initial access procedure. So we also published that. All of that is available to our partners. So we are a partner in 6GXL. We are a partner in Accord, as Tracy mentioned. So remote users have access to the testbed through us, of course. It needs to be negotiated with us. But you can set up a VM and then set up your own topology and control the radios. I'm very interested in international collaboration. So I spent part of my career in the US, part in Ireland. This kind of collaboration is the thing that I like most probably in the world in terms of work. So I'm really keen to see if we can build some additional collaborations within the umbrella of 6G Excel. Just a little plug, we, as I said, work a lot with SRS. SRS holds an annual workshop in the US. It's taking place tomorrow and Wednesday, and we host that workshop as well. So I know that some people from here are actually going to be going there tomorrow for that. So that's all I have, and I'll be happy to take questions or discuss in the roundtable. Thank you.